Hello everyone. I'm excited to introduce our framework called AEGIS, Human Attention-Based Explainable Guidance for Intelligent Vehicle Systems. Autonomous vehicles are shaping the future of transportation, but have you ever wondered what they actually see? Modern autonomous driving relies on deep neural networks that map sensor data to driving actions. However, these systems function as black boxes, meaning we don't fully understand what the vehicle perceives and how it makes decisions. Why is this a problem? Let's take a look at a classic example in computer vision, the husky versus wolf problem. A machine learning classifier was trained to distinguish between huskies and wolves, achieving 80% accuracy. But when researchers examined its mistakes, they found something surprising. Instead of recognizing the animals themselves, the classifier relied on spurious correlations. It associated wolves with snowy backgrounds. As a result, a husky standing in the snow was often misclassified as a wolf. This issue highlights a major challenge in AI. Machines don't always learn what we expect them to, leading to ethical concerns in computer vision. When it comes to autonomous driving, each spurious correlation can be dangerous. Let's look at a real example. We visualize the machine's attention in an autonomous driving model. The model successfully turns left, but not for the reason we expect. Instead of focusing on the road, it's relying on the sidewalk as a reference. Now, what happens in a new scenario where the sidewalk is missing? The model fails and crashes into oncoming traffic. This highlights a critical flaw. If we don't understand what autonomous vehicles are actually seeing, we can't trust them to make safe decisions. Unlike machines, human drivers have a sophisticated visual and cognitive system that helps us filter out distractions and avoid spurious correlations. When making driving decisions, we instinctively focus on the most important objects, like other vehicles, pedestrians, and traffic signals, rather than irrelevant background elements. In natural language processing, aligning machine intent with human understanding has been widely studied. But what about driving? Can we use human attention, our selective focus, to guide autonomous vehicles and make them safer? This is where AEGIS, Human Attention-Based Explainable Guidance for Intelligent Vehicle Systems, comes into play. To align autonomous driving with human attention, we first need real human eye movement data. We achieve this using the Kala simulator and a VR headset, creating an immersive and realistic driving experience. This setup allows us to capture where human drivers naturally focus their attention, all while keeping costs low and engagement high. With this data, we can guide autonomous vehicles to see the road like a human does. We designed a series of experiments with 20 participants to capture human eye movements across 6 key driving scenarios. These scenarios include car following, intersection crossing, and pedestrian interactions. Using this data, we convert raw eye movements into human attention maps to represent the complex decision-making process of real drivers. We then use this human attention data to train an AI attention model, guiding machine perception to focus on the most critical aspects of the road, just like a human would. Now, let's take a closer look at our model architecture. We designed an interpretable module using a self-attention layer within our policy network. This allows us to visualize how the machine allocates its attention, making its decision-making process more transparent. More importantly, we use KL divergence loss to align machine attention with human attention, ensuring that the AI focuses on the most critical areas, just like a human driver would. We visualized machine attention and compared models with and without human attention guidance. In the left turn scenario, without human attention guidance, the model focuses on irrelevant details like the sidewalk and fence. It uses these incorrect cues to turn, which leads to failure in unfamiliar test environments. With human attention guidance, the model prioritizes critical elements such as oncoming vehicles. As a result, it successfully executes left turns in both training and testing scenarios. In the car following scenario, without human attention guidance, machine attention tends to be more dispersed. This leads to an earlier collision with the lead vehicle. With human attention guidance, the focus is more concentrated on the lead vehicle. It's like giving the agent a hint when it's confused. This makes the learning process way faster and more efficient. Therefore, AEGIS can brake swiftly in reaction to the abrupt brake of the lead vehicle. Without this guidance, the AI might overfit, performing well in training but failing in unseen scenarios. With human guidance, it adapts and learns faster, braking or turning just like you would. Think of it as the AI asking for your help when it's confused, making it smarter and safer. Beyond just visualizing attention, we also rigorously tested AEGIS for real-world safety based on 3 metrics: success rate, survival distance, and the time to collision. The results show that AEGIS consistently outperforms the methods without human attention guidance. To assess how well human drivers can interpret machine attention visualizations, we conducted a user study. Participants watched the visualization results we presented earlier and answered 3 key questions. How easy is it to understand the AI's decisions? How well do the visualizations align with vehicle actions? How confident do you feel in the model's safety and reliability? We asked them to rank the videos based on clarity and trustworthiness, helping us measure the interpretability of AEGIS in highly interactive driving scenarios. We recruited 80 participants with driver licenses from Prolific. The result shows that AEGIS has the highest ranking compared to methods without human attention guidance in all the 3 questions. This demonstrates AEGIS is more interpretable to human drivers. We also conducted a case study visualizing AEGIS's attention on a real-world video. While the result is promising, further investigation into real-world scenarios would be interesting future work. With AEGIS, we hope to demonstrate it is beneficial to include human involvement to build a better AI. We hope this framework can contribute to the HCI community, paving the way for future AI systems that align more closely with human expectations, making AI-driven decisions more transparent, trustworthy, and effective.